All right, welcome to this video. In this video, it is the start of the series of sketching functions, and we're going to sketch function using derivatives. So what I want us to start with initially is to determine the steps that we need to take in order for us to sketch these functions. So the first thing that I'd recommend that you do is to find the intercept with the x's. So normally in our two-dimensional Cartesian plane, we've got the y and the x-intercept. And just remember that whenever you're finding the y-intercept, it's essentially where x is equals to 0, and wherever we're finding the x-intercept is essentially where y is equals to 0. And you just have to solve for the respective part. The second thing we will do is to determine the turning points, or sometimes they call these stationary points. Okay, so stationary points, later I'll use the term TP for short. And therefore, what you then do there, you let the derivative equal 0, solve for the respective x value, and then get the y coordinates that give you the turning point. The next thing you want to do is to classify these turning points, and you use the second derivative. You'll see now when I go through the examples, what do we mean by that? So from there, you'll be able to determine whether a point is a local minimum or it is a local maximum point. So when you classify it, that's exactly what you'll mean. And then later in the series, not in this first or the second video, we have to deal with some rational functions. So normally in rational functions, we'll have vertical asymptotes, which I will write for short as VA. We will have horizontal asymptotes, which I'll write short as HA. And then we're going to have oblique asymptotes. Sometimes they're called slant asymptotes, but we'll deal with the term oblique asymptote. But we'll only get to this once we're doing rational functions. So what I will do is do like a video with just a vertical asymptote, do a video with just a horizontal asymptote, do a video with just an oblique asymptote, and then do a video with two of these asymptotes that exist. Okay, so let's dive right into it. So whenever you are sketching functions, you need to realize the following properties. So first of all, you need to determine when a function is increasing or decreasing, and we can do that by the first derivative. So you'll see that when the first derivative is positive, then the function is increasing, and then you will see that in every single area where there's an increasing function, the first derivative is positive at all times. So it is absolutely important for us to be able to notice that. Except this is not correct. So here the first derivative should be small and the function should be decreasing. That is the most important thing. So where the derivative is negative, that's where the function is decreasing. Very important to note that. I'm not sure if this is used in our curriculum, but if you have the first derivative at a point is undefined, you'll have this particular thing which is called a cusp. All right, basically it's just a sharp point over there. But I think it's important that you know it. So it's where the derivative is undefined, you'll have a cusp, and therefore it's quite important for you to know that. And then where the derivative at a particular x value equals to 0, that's where we've got a turning point. Okay, very important for you guys to know. And then similarly here, where the derivative equals to 0, you've got a turning point as well. And where the derivative is equals to 0 gives you another turning point. We will then use the second derivative to determine what type of turning point it is. Is it going to be a local max or is it going to be a local minimum? So let's check to the next bit. Okay, so now we now know that if we are taking what we call the first derivative, from the first derivative, we are able to now start defining certain points. So we now take the second derivative. So where the function has got a second derivative, equaling to 0, where the second derivative is equals to 0, we call that point a point of inflection. All right, so that's very important. But also the point of inflection is where a function goes from being concave up, as you can see the shape, to concave down. So concave down will be that shape that you get over there. So that's absolutely important for you to know. So remember that to get to this turning point over here, So for example, when the second derivative is positive, we will then have a local minimum. And where the second derivative is positive, we'll have a local maximum. So these are some of the important things that we need to know. And then in between the points of inflection, you'll find that a function increases and decreasing depending from which type of turning point it comes from. So let's have a look at this one again here on the side. So the derivative is equals to 0, but the second derivative is negative. So that's where we get a local max. And then this side, the second derivative is positive. We now have a local min at that particular point. So this is all essential for us to know. But what we will do, we will sketch two functions in the next two sets of videos that get to show how we are able to do this. So I hope this is making some sense, but we will now apply this in examples. So see you in the next video.